So what did you just experience? Well, it was a sort of asynchronous and developed for online version of what we call a CS Unplugged activity. And these have been around for quite some time. They actually were first developed by a group in New Zealand, but now this is sort of a more general term. And the idea is that we can learn about computational thinking or computer science concepts without actually having to have a computer. So what's the benefit of that? Well, first off, we want our students to understand that computer science and computational thinking concepts have uses in the real world. And so we would like to draw on their already existing knowledge of things that they can do in the real world to help introduce those concepts. The other thing, and this is pretty important, is that there's a lot less distraction sometimes when you're not using a computer, right? Students can't either be distracted by other things or the computer, or even just the using of the computing program that you're doing yourself can be that a distraction. Also, sometimes we have access to computers every day for our students. So one of the key things about CS Unplugged activities is that in general you'll find that most of them are designed to introduce a computing concept. And we're generally going to be doing that before we go and write a program the first time using it. And because, again, we want to sort of get them in a less distracted way introduced to the concept without focusing on details. And then we're actually going to find, usually going to introduce the concept and have people use it in a program before we go and do things like define terms. And why is that? Well, if we're introducing people to some concept that's new to them, and the term, say, instruction for a computer, that may not be, the definition of that might not mean anything to a student if they haven't already had some experience with it. This is maybe different than other ways that we introduce vocabulary in schools, where, for example, with the word afraid, well, no matter what, unfortunately, our students have probably all had a little bit of experience with the concept of being afraid before they get to us. So we can go ahead and provide that definition, but they already have had a real-life introduction to it on their own. We just know that with computing concepts, we are going to have to provide that real-life introduction ourselves with the students. So what we just did is part of a lesson plan that is produced by this organization called code.org. That's their icon up there. We're going to be using a number of their materials from especially their Unplugged activities, but also going to be reinforcing some of our programming concepts with their materials because A, they're freely available and they're pretty well designed. So what was it that hopefully you got out of doing that experience? Well, hopefully it was the realization that probably in the past, and certainly when given the impetus to do it with those cups and the arrows, that you could take a task that maybe is kind of complex, building up this tower, and you could provide a set of instructions to do it, okay? Two of the key things that came out of that is that the instructions that you were able to give were really, really simple, right? Just these arrows, and that you would give them in an ordered list. The order in which you did them was important. Now, maybe students wouldn't have gotten all of that out of it, maybe didn't just by doing it, but in a debrief like this, these could be things that we could go over with students in more detail. What happens if you change the order that you have them, the instructions in? Would you get the same response, etc.? Right. So again, our students really do have experiences in things in the real world that they can already break down these more complex tasks into a set of instructions. So pretty much I think any kid, even starting in kindergarten, could in some way describe what the steps are that happen for them to get up in the morning and brush their teeth, get dressed, eat their breakfast, whatever it is, all the steps that get them out of the door to go to school. However, one of the things that will come up in discussing this is, well, if you just said eat breakfast, that's kind of a complex set of things. Like, what does that mean? Do I put the pancake syrup on? Do I not put the pancake syrup on? Do I have a fork? How do I use the fork? And so, in fact, that particular eat breakfast task might then be something that, especially if we were talking about giving instructions to a computer, we'd have to break down into smaller, more simple steps. And that becomes one of our key concepts. I'll go ahead and give you the vocabulary word because you're adults, abstraction, that we'll be coming back to and continuing to through this entire course, develop our conceptual understanding of what that is. So the key thing to take away is that in this chapter of our work, you're going to learn to break down complex tasks into smaller pieces that will be specifically instructions you'll give to a computer. So what's that look like? Well, the primary language that we are going to be using to teach you and introduce you to the core computing concepts is called SNAP. It is what's known as a block-based language, and that basically means that all your instructions look like these. They're individual blocks that you don't type them out or anything. You just select them and you can drag them around, and you can see these are actually sort of clicked together. They look a little bit like puzzle pieces, right? So they have a way that they fit together. SNAP was developed at Berkeley, and it's freely available. One of our reasons for choosing it is that it supports very novice people getting started, but actually, if you have some prior programming experience, there's a whole lot of advanced things that you know about that SNAP probably also supports. So, just as an example, our first instruction here is move 10 steps. Then wait 1 second. All right. Turn 90 degrees. Is that like that? Say hello. What kind of instructions are we giving to this computer? Are we asking our computer to do all of this? SNAP is like many block-based languages in that we're going to be giving instructions for something called a sprite. Okay? You may also want to refer to this as an object. This is, I think it's Alonzo. He's the default sprite in SNAP that they designed, but that we will find that there are many, many other sprites that we can give directions to that allow us to create really interesting programs that maybe represent things that we want to create. So for example, we have a number of pictures of people in different sort of stances, so we can have them doing dancing. We have a girl playing basketball. There are many, many animals, etc. So there will be a lot of different sprites that we can use to sort of make interesting programs of our own design. Finally, let me just come back to this unplugged activity. Later on, after we've learned about programming in SNAP using sequences of instructions, we'll come back and review in more detail the particular lesson plan that code.org has. So you don't need to spend the time to go look at it right now. We'll look at it in detail and we'll critique it and try to understand how we might be able to modify it to use it in our own classes.